Hi, I'm Regan Pauri from IISc Bangalore, and I will be presenting our upcoming ASE 25 paper titled RFCScope, Detecting Logical Ambiguities in Internet Protocol Specifications. I did this work in collaboration with Li Zhou, Human Lee, Yisin Sun, and Wenxi Wang from the University of Virginia. Internet protocols and standards such as TCP, HTTP, and DNS are defined in documents known as requests for comments or RFCs published by the Internet Engineering Task Force or IETF. These documents combine different formal and informal elements like natural language, pseudocode, formal notations, diagrams, tables, and so on. They are written by humans and are therefore prone to ambiguities, which can undermine their interoperability and implementation correctness. The infamous Heartbleed bug from 2014, which exposed massive amounts of private data, can be traced back to an ambiguity in RFC 6520, which led to a bug in a widely used implementation of TLS heartbeats. Similarly, this year, CADI, a widely used web server, began failing to connect to many internal servers because of incompatibility between DNS resolvers, which arose out of ambiguities in RFCs 9460 and 9461. No prior work has focused on identifying logical ambiguities in RFCs, and we present the first framework to address this problem. RFCs once published don't change, but IETF provides a system to report errors or errata in RFCs to maintain a record of issues that will be fixed in future RFCs. We conducted the first study of technical errata reported in Standards Track RFCs published in the last 11 years. We analyzed 273 such reports and classified them into two main categories: inconsistency and underspecification, each with further fine grained subcategories like direct inconsistency between or across specifications and direct underspecification due to undefined terms. For instance, this erratum reports the direct inconsistency between two RFCs 7598 and 7599 over the maximum value of DMR IPv6 prefix. RFC 7598 says that the value ranges between 0 and 128, while RFC 7599 says that the value can exceed 96. Similarly, this erratum reports that the term active SSRC used in RFC 8888 has not been defined in that RFC. Now, LLMs or large language models show great potential for analyzing natural language specifications to find such issues. First of all, they can process diverse forms of content like text, code, tables, and diagrams. Secondly, they are capable of performing complex reasoning. And third, they possess common technical knowledge about internet protocols, which they can apply in different situations. At the same time, there are many challenges in applying LLMs for this task. RFCs are often very long, which can affect the quality of responses by the model. This challenge becomes even more significant because each RFC typically references many other documents, which must also be considered during the reasoning, which makes it difficult to fit all the relevant information within the LLM's context window. Moreover, LLMs often lack the specific domain knowledge needed to detect ambiguities in RFCs, and they can sometimes produce results that sound plausible but are actually incorrect. To address these challenges, we propose our framework RFCScope for detecting logical ambiguities in RFCs. Given an RFC document, we first use the context constructor to build its context, which includes all referenced RFC sections and summaries of any non-RFC documents. Here's the detailed pipeline of our context constructor. Given an RFC document, it processes each paragraph, parses it to identify references to other documents, and then gathers the relevant sections from all those reference documents. For an RFC referenced with a specific section number, it directly collects that section. Otherwise, it uses semantic search to find the best matching section. For non-RFC documents like websites, it summarizes the contents of the reference document. All of this, along with the input RFC, forms the context of the given paragraph. After this context is extracted, RFCScope employs the partitional component to split the RFC along with its context into smaller segments that each fit within the LLM's context window. Each of these segments can now be given to the LLM as a whole for processing. Each segment is first given to the analyzer. Here, the LLM is prompted to identify ambiguities in the given segment with the provided context and, most importantly, insights and findings from a study. These insights include the types of logical ambiguities to detect, the strategies to find them, and also real examples that illustrate each type of ambiguity. The initial errata from this step are then given to the evaluator. The evaluator is then an LLM judge, which evaluates these initial errata and filters false positives by validating the reasoning steps given by the analyzer, checking each erratum against a checklist criteria for plausible errata, and identifying the ambiguity category that each erratum belongs to. This checklist consists of points that address whether the information in question is mentioned elsewhere in the document, whether it is intentionally left to the user's discretion, whether it is even relevant to this document, and so on. Finally, these remaining errata reports are manually inspected. In this step, we refer to several key sources, including draft RFC versions from IETF Data Tracker, discussions between authors of the RFC from the IETF mail archive, and commit history, pull requests, and issues from GitHub. We evaluated RFCScope on 20 recent RFCs related to the domain name system or DNS, an important internet standard. This figure shows the number of ambiguities identified at each stage of a pipeline. The analyzer reported initially 281 errata, which were reduced to 137 by the evaluator. We finalized 31 confirmed reports after manual inspection. Out of these, 17 were inconsistencies and 14 were under specifications. 8 of them have been confirmed by RFC authors, and 3 have been officially verified on the IETF portal. By detecting ambiguities in RFCs early on in the drafting process, RFCScope can help authors produce clearer and more precise specifications, ultimately improving the quality of Internet Protocol implementations. To summarize, we conducted the first study of territorial errata from RFCs to propose a taxonomy of logical ambiguities. We developed the first framework for detecting these ambiguities in RFCs, and we demonstrated the real-world impact of our approach by discovering 31 previously unreported logical ambiguities in 14 recent RFCs. Thank you for listening. I look forward to seeing you at ASE.